Welcome to Unit 1, Part A. What you will learn today are the commonly used electrical quantities and their units. This is an label print on an electrical kettle. This line means that the kettle should be powered by a 220 to 240 volts AC source, 50 or 60 Hz. The tilde sign represents alternating current AC source. All power sockets in your Singapore home fit these requirements. The next line, 2000 and 2400 watts, tells us the power consumption of the kettle. Now, you may be wondering what all this means. Don't worry, you will know that soon. Another label on a laptop power adapter. Input 100 to 240 volts AC, 1.3 amperes, 50 to 60 Hz. These are the input requirements of the adapter. All power sockets in your Singapore home fit these requirements. The next line, output 20 volts. This symbol represents direct current DC. 2.25 amperes. This tells us that the adapter can provide a 20 volts DC output voltage with a maximum output current of 2.25 amperes. Now you retract the battery from your camera and notice these figures. They tell us that when the battery is fully charged, it provides a DC output voltage of 3.7 volts, and the amount of energy stored is typically 1000 milliampere hours, minimum 940 milliampere hours, which is approximately equal to 3.5 watt hours. mAh and Wh are units of energy. This data tells us the capacities of the battery. LiION means that this is a lithium-ion battery. You have just seen some of the common electrical quantities, such as voltage. The symbol for voltage is V. To show that it is a variable, we often print a quantity symbol in italic. The unit for voltage is volt. The symbol for volt is also V, but we should always print a unit symbol in regular font, not in italic. You have also seen the quantity current. Its symbol is I, and its unit is ampere, represented by a capital letter A. The symbol for power is P, its unit is watt, W. Frequency is F. Its unit is Hz, Hz. Take note that it is a capital letter H followed by a small letter Z. Resistance is R and Ohm, that will be covered in Unit 3. Energy is W, its unit is Joule. Time is T, its unit is second. Let's look at the label of this electric iron. You can see the values and the units of voltage, frequency, and power. But usually you won't see the quantity symbols on a label. The first line prints the power supply requirements, 220 to 240 volts AC supply, with a frequency of 50 or 60 Hz. The second line, 1500 watts, is the power consumption of the iron. An electrical appliance requires an input voltage of 240 volts operating at a frequency of 50 Hz. Let's summarize these requirements to two equations. The symbol for voltage is V. The symbol for the unit volt is also V. Hence, we write V is equal to 240 volt. Typing this V in italic or writing it in script letter can differentiate from the unit of volt. Variable symbols are often printed in italic or written in script letters. The symbol for frequency is F. The symbol for the unit Hertz is Hz. Therefore, we can represent this frequency is equal to 50 Hz. Second example. An electric kettle provides an output power of 2400 watts when operating in 230 volts and a frequency of 50 Hz. The symbol for power is P. The symbol for the unit watt is W. Therefore, we write P is equal to 2400 watts. For the input voltage and frequency requirements, we write V is equal to 230 volts and F is equal to 50 Hz. Another example of using equations to represent these electric specifications. An AC adapter draws an input current of 1 ampere from a power source of 230 volts and delivers an output voltage of 20 volts and an output current of 2 amperes. This 1 ampere and 230 volts are the input specifications of the power source. Therefore, we write V in is equal to 230 volts and I in is equal to 1 ampere. The two words power source do not refer to power consumption or participation of the AC adapter. Therefore, we do not write an equation, P being equal to a value in the unit of watts. The next half of this sentence is the output specifications. We can summarize them as V out is equal to 20 volts and I out is equal to 2 amperes. Let's recapitulate what you have learned. Electrical quantities and units are found in all electrical appliances. A label provides useful information of an electrical appliance. Quantities and units can be represented in their symbols. After you have completed the quiz of Part A, we will discuss Part B, Scientific Notation.